I am now going to show you how to define time discretizations with LASPATED. These time discretizations are obtained with the add time discretization method of LASPATED. And there are three ways of defining time discretizations with LASPATED. First, defining periodic time windows where each period is divided into elementary time windows of the same duration. For the second type of time discretization, we also have periodic time windows, but each period is divided into elementary time windows of different durations. And finally, we have customized time discretization. So let us consider the first situation, the simplest discretization, where we have periodic time windows, where each period is divided into these so-called elementary time windows of the same duration. The duration of the elementary time window is specified in the second argument of the method at discretization, while the time unit of this duration is given in the first argument, and this first argument is a string with possible values y for years, m for months, w for weeks, d for day, h for hours, little m for minutes, and s for seconds. So as an example, let us assume that we want to count the number of arrivals for every day of the week. So we will take as the duration of elementary time window 1 day. So the first argument will be the string d, because the time unit is day. The second argument is the duration of the elementary time window. Let us take it of 1 day. And the duration of the period in the time unit of the first argument of the method, so in days for us, is specified in the third argument of the method. Therefore, this first argument needs to be a multiple of the second argument. It is the duration of elementary time window, which is 1 day here, times the number of elementary time windows in a period. So if the elementary time window for us is 1 day and we want a period of 1 week, then the third argument needs to be 7. So with this command, add time discretization D17, we have added a time discretization that can be used, that is used to count the number of arrivals for every day of the week. Now, if we want to visualize the corresponding space-time discretization, we record that the space discretization that we have used is by hexagons, and now we have defined this time discretization. Then we can use the LASPATED method, get events aggregated, app.get events aggregated. We can see the dimensions of A. A will be an array, actually a data frame object that will contain the events plus enriched information with columns corresponding to space and time discretization. So the dimensions of A are 7. This corresponds to the time discretization because the period is 7 days. So we want to count the number of observations for every day of the week here. The second dimension, 226, this is the number of subregions in the space discretization. We recall that the last one that we have used is by hexagons, and we have 226 hexagons. And 4 is the number of call types of priorities. So for instance, if I want to see for the day of the week with index 0 and hexagon, say with index 12 and calls of priority 0, what is the number of calls for this day, this region, and this priority, then I will access to the entries 0, 12, 0 of A. Let us now add a time discretization in time windows of 30 minutes for every day of the week. We are still going to use the add time discretization method. App.add time discretization. And if we want now to define elementary time windows of 30 minutes, we will use M, the string M, for the first argument of add time discretization. The second argument will be the duration of an elementary time window, which is 30 in minutes. And then the third argument is the duration of a period, 1 day. So in minutes, this gives 60 times 24. And we can, additionally, if we wish, give a name to the column corresponding to this time discretization. So it could be half hour index. So we can, as before, access the spatio-temporal discretization information using the get events aggregated method of LASPATED. And this will be stored in an array A. Get events aggregated. And then we will check the dimensions of A. Now for time discretization, we will have 2 indexes. One for the day. So we have 7 indexes for every day of the week. And one for every time window of 30 minutes during the day. We have 48 such indexes. So let us check the dimensions of A. So the first dimension is 7. This is the number of days in the week. The second dimension, 48, is the number of time windows of 30 minutes during the day. So the first 2 dimensions correspond to time discretization. Then the third dimension, 226, corresponds to space discretization. This is the number of hexagons of our space discretization. And 4, this is the number of arrival types. We have 4 priorities in the case of our observations. And now in the entries of A, we have for all combinations of time indexes, space indexes, and priority indexes, the corresponding sequence of number of arrivals, number of calls. So for instance, in A of, say, 0, 0, say 10, 1, we have the sequence of the number of arrivals, number of calls, for day with index 0, for the time window of 30 minutes with index 0, for the hexagon with index 10, and for calls of priority 1. Oh, in this situation here, we had no such calls. Let us change the day index. So here, for instance, we have only observed once, one call for day with index 3, time window with index 25, hexagon with index 30, and call of priority 0. For the previous combinations of indexes, we had observed no calls. Let me now comment on the second time discretization function offered by LASPATED. For this second function, we still build time discretizations that are periodic, but with elementary time windows of different durations. The corresponding time discretization is obtained with the add time discretization method of LASPATED. The first argument is, as before, a string that indicates the unit of the durations. So let us take months. The third argument is the period of the model. So let us take a yearly model, 12 months. And the second argument is a list providing the durations, here in months, of the successive elementary time windows. So assume we want time windows of successive duration 3 months, 4 months, 2 months, 1 month, and 2 months. Then this is how we would build the corresponding time discretization with LASPATED. And we can also give a name to the corresponding time discretization column. Let us call it variable time index. So for this time discretization, we have a model which is periodic with period 1 year, 12 months. And we will count the number of arrivals for the first 3 months, then the next 4 months, and the next 2 months, then for the next month, which is October, and then for the last 2 months, which are November, December. For the third argument, we actually need to put a multiple of the sum of the durations in the array that is in the second argument. The sum of these durations here is 12. So the third argument is a multiple of 12. It could also be, for instance, 24. If it is 24, then this means that we would count the number of arrivals for the first 3 months of odd years, then the next 4 months of odd years, then for odd years for the next 2 months, the next months, and for November, December. And also for even years, we would count the number of observations for the first 3 months, and the next 4 months, next 2 months for October, and then for November, December. As before, we can obtain the data corresponding to space-time discretization using the get events aggregated method of LASPATED. So A is app dot get events aggregated. We will check now the dimensions of A. We added an additional time discretization. So before, the dimensions for time discretization were 7, 48. And now we have added a time discretization that has 5 indexes. So if we print the dimensions of A, then we will get for the first 3 indexes, the indexes corresponding to time discretization. So this is 7 for the 7 days of a week, 48 for the 48 time windows of 30 minutes during the day, and 5 corresponding to these 5 blocks of months that we have defined in the last time discretization. Then we have the index corresponding to space discretization, the hexagons, and then the index corresponding to the features, the priorities in the case of the calls. So for instance, we could access A of 3, 21, 2, 34, 3 to get the successive number of arrivals of calls for day with index 3, for time window of 30 minutes with index 21, for the group of months that we have defined in the last time discretization with index 2, for the hexagon with index 34, and for the priority 3 of the calls. And here we have observed only once one call for these indexes. Finally, let me show you a last time discretization function offered by LASPATED. We can specify more general time windows like holidays or special events defined by the user. And LASPATED allows such flexibility by defining a set of customized time indexes for time intervals. In this situation, the user needs to provide a data frame with the following columns: start, the index start time, end, the index end time, t, the index number, and repetition, which informs whether the index should be repeated in different years or not. So let us see an example building the corresponding data frame. Let us call time disk df, this data frame. And for this example, assume that we would like to count the number of observations for January 1st, which is holiday, and for Carnival. In our example of emergency calls to Rio de Janeiro Emergency Health Service, the history of calls that we have is for 2016 and 2017. So since we want to consider the Carnival as a special event, we will provide the dates of Carnival for 2016 and 2017. And also we will say that January 1st is holiday, and we would like to count separately the number of observations for January 1st. So let us start with January 1st. So our observations start in 2016. So 2016, January 1st. is the index start time. Then we need to provide the index end time, which is also January 1st, 2016. The next argument is an index number for January 1st. Let us say that we use the index 1. And then a string that informs whether the index should be repeated in different years or not. If it is repeated in different years, then we use the string yearly. Then we provide information for the dates for Carnival in 2016. Then we will do the same for Carnival in 2017. And finally, we can give names to the columns which will be start, end, T, repetition. So let us feel what is missing. The dates of Carnival for 2016 and 2017. So for 2016, it starts in February 6th. It ends on February 11th. Let us say the index will be 2 for Carnival. And there is no repetition since the dates of Carnival depend on the year. And same for 2017. The index will be 2. There is no repetition. And we provide the dates of Carnival, February, which are February 24 until March 6. March 6. So let us check the dates for Carnival 2016. For 2017. January 1st. Okay, so we have defined a data frame corresponding to this new time discretization. And then we again use the add time discretization method. Of LASPATED, passing as arguments this data frame object. And again, as before, we can access the spatio-temporal information of discretization using the get events aggregated method of LASPATED. So let A store the corresponding information. This will be at dot get events aggregated. Now it will take more time because we have more time indexes. We will again check the dimensions of A. Now we will have 4 time indexes. We will have a space index and an index for the feature, for the priority. So let us print the dimensions of A. And as I was saying, now we have 4 dimensions for time discretization. These are 7, the number of days in the week; 48, the number of time windows of 30 minutes during a day; 5, the number of months block that we have defined in the third discretization; and then 3 corresponding to the indexes of the last time discretization. The next index will be for hexagons, for the hexagons of the space discretization, and the last index will be for the priority of the calls. So for instance, if we access A of 0 at 23, or say as before, we are going to take 3, 21, 2. Say 0, 100, and here say 0. This one here means that for this combination of indexes, we have once observed one arrival, one call. And what is this combination of indexes? This corresponds to what we have, the sequence of arrivals for the day with index 3, the time window of 30 minutes during the day with index 21, the block of months with index 2. We remember that we have defined in the third discretization 5 blocks of months, and each of these 5 blocks have an index. Here we access to the months, to the block of months with index 2. And for the last time discretization, we have 3 indexes. The observations that are for January 1st, those that are for Carnival, and those that are neither for January 1st, neither for Carnival. So we have 3 indexes, and here we access the observations with for index 0 for this time discretization. We are interested in hexagon with index 100 and calls of priority 0, and so on, or other combinations of indexes.